Now, just building on the concept of Earlian circuits will only exist when we've got all of the vertices even. So in this first case, we've got a total of 0 odd vertices and a total of 4 even ones. So yes, it will exist. In the case of the second example, 1, 2, 3, 4, all of the vertices are even. So yes, that will exist as well. Moving through to the third example, you can see here I've got 2 evens, 2 odds, no. If you'd like to experiment with that, that's going to have an Earlian path option as well. In the next instance, no, because we've got a total of 2 odd and 2 even vertices. Rule of thumb, if there's any odds, it's not going to happen. If there's 2 odds and the rest are even, we could actually form an Earlian path. In this next example, we've got all the vertices are even. There are no odds, so an Earlian circuit can exist. In the next instance, they're all odd, so no, there are no evens. In the next instance for G, takes a bit more checking, yes, and all the vertices are even, so 1, 2, 3, 4, 5, 6, 7, 8. In this next instance, we've got everything as even, so an Earlian circuit can exist. A total of 5 and 0. We'd have to try and redraw. That would be actually quite messy, but with that situation it could exist. In number 3, you're asked to predict whether it's possible for an Earlian circuit or Earlian path to actually exist. In the case of A, you can see here every degree, every vertex is of an even degree. So all even, yes. In the case of B, they are all even. So yes. The case of C, you can see here that both C and DN are odd. The rest are even. So yes, that can occur for an Earlian path only. For D, in the case of D, all are even. So yes, an Earlian circuit exists. Now, I'll work through the case of C, and I'll leave you to draw and work out, label an Earlian circuit in those cases. So we'll have a look at C and an Earlian path example. Now, for an Earlian path to exist, we've got to start at one of 2 of those odd vertices and work it through. And we finish back at Dn. I'll just write the summary for that. Please notice you can have variants of this, and obviously if I start at Dn, I'll have some alternatives to that answer I've presented.